Let's try one more. Okay, there are lots of different examples out there, and I wish I could show you every single one. So if you've got questions, let me know about setup, different things. Like, I'm here to help you best I can. Okay, all right, let's dive in. Water is flowing into a vertical cylindrical tank with a diameter of 6 meters at the rate of 5 cubic meters per minute. Find the rate at which the water is rising. All righty, starting out with the given information. So this cylindrical tank is pretty important here. That's going to help us figure out the formula that we need to use. Meters cubed. Meters cubed tells us what? Volume, right? So that means they've given us the rate of our volume, which is 5 cubic meters per minute. And we know the diameter is 6 meters. Cool. Okay, so again, we've taken out the cylindrical piece, we've taken out the rate of our volume, and we have the diameter of 6 meters. So now we need to know what is being asked of us. It says find the rate at which the water is rising. So that's the height of the water. So it wants to know dH dt. Get ourselves a sketch here. So we have a cylindrical tank. Looks something like this. That's really ugly, but you get it. Okay. So to start out with my calculations, let's look at what's given and what's being asked. They've given us diameter, volume. They're talking about the rate of the volume, and they want to know the rate of the height. So I think here we're going to use, again, our volume formula. Pretty standard approach there. So here my volume of a cylindrical tank is pi r squared times height. Okay, so we have our radius and our height here. Gives us the volume of our tank. So if we're talking about rates of change, we need our derivative. This one here has a product rule. Okay, it is r squared times h, so we have to use the product. So derivative of v is dv dt. So here's my left. That's pi r squared times the derivative of h, which is dH dt, plus left derivative of the right. That's going to be 2 pi r dr dt. Okay, we could simplify that, clean it up a little bit, but we're just going to be plugging stuff in anyway, so let's see what happens. So we need to solve for dH dt, so let's plug in what we know here. All right, so my dV dt is 5. 5 equals pi. My radius. I don't know my radius, but I know my diameter. And the relationship between the diameter and the radius, the diameter is twice the radius, so my r is going to be 3. Right? If diameter is 6, I now know my radius is 3. Okay, we're solving for dH dt, so we're going to leave that alone. H, my height. They didn't tell me my height, did they? And I don't have any information to figure that out. So let's leave that for a second, see what happens here. dr dt. They also didn't tell me my dr dt, so what's the rate of change of my radius? Well, if I look at my sketch, not my sketch because it's awful, but think of a cylindrical tank. This radius is the exact same radius that entire tank, right? So is that radius changing? No, it's not. So if the radius isn't changing, its rate of change is 0. So I might not know what this height is, but I'm going to end up timesing it by 0 anyways. So that's going to go away. So I have 5 equals 9 pi dH dt. So I'm going to divide by 9 pi. And my dH dt equals 5 over 9 pi meters per minute. Okay, so here's my answer. And is it possible? Yeah, I think we're all right. Okay, water is rising, which means it's increasing. We got a positive answer. Things look good. Okay, good luck. Keep solving.